So on your table of contents, we're going to our next number. I believe number 41. Okay. And we're going to title it Solutions. You guys see that orange? Yeah. Solutions of equations and inequalities. And put your next number, then turn to your next blank page. Right. Okay, and make sure you give it a title. Solutions of equations and inequalities. Alright guys, so today we are going to determine whether a given value is a solution or if it's an inequality. So to do this, we have to understand what value will make x equal. And we're going to show we can do this by solving equations and inequalities. So we're going to start with a little vocabulary. Before we can do this, we have to know what a solution is. So we're going to write down the definition of a solution. And a solution is a number that can be substituted for the variable to make a true statement. Let's write that down. We also need to know what it means to solve an equation. And literally that means to find a solution. There we go. A solution. So when we're solving, we're really looking for a number that could be substituted for a variable to make our statement true. So these two words are tied to each other. And you're going to see them in your direction. All right. So we're going to look at some examples. So the first example, you can put number 1. We have 5x minus 3 equals 17. So looking at my definition, if I have to solve this equation, then I'm looking for a number that could be substituted for my variable to make this statement true. My variable is x in this example, right? Okay, so a couple ways I can go about this. One method is guess and check. So I can look at this and think to myself, 5 times what number? number is next to a variable, I know it means time. If I think x is 4, then I would put a 4 minus 3 equals. Order of operations says, what should I do first? Kyle.
Multiply 5 times 4.
5 times 4 is 20. Then I just have 20 minus 3, which gives me 17. So my answer to this one is x equals 4. So I showed my thinking by showing each step. All right, let's look at a second example. This time I have 1 plus 4x is greater than 3x plus 1. So for this problem, the first question I have is this an equation or is this an inequality? Trey. Yeah, that greater than sign means it's an inequality. Let's go ahead and solve it for x equals 9. So one thing I'm noticing is we have 1 plus on this side, and we have plus 1 over here. So I just don't want to forget those. So if x is 9, then I'm going to rewrite it as 1 plus 4 times 9 is greater than 3 times, if x is 9, plus 1. If it's true, then when I solve it, this value should be bigger than this one, right? Okay, order of operations tells me to do multiplication first. What's 4 times 9? 36. I still have 1 plus. What's 1 plus 36? 37. Nice work. Okay. So 37. Now let's do this side. What's 3 times 9?
27.
Okay. Plus 1. Don't forget that plus 1. What does that give us?
28.
28. Is 37 greater than 28?
Yes.
Yes. So x equaling 9, that is a possible solution for this inequality. Could x be other numbers to make it true? Yes. And sometimes they'll ask you for more than one possibility, right? We did that a little bit on Friday. All right, let's look at another example. So you can put number 3. This time we have 2x plus 6 equals 8 plus 6. What does x have to be? Okay, hands down. Let's work through this and see if you're right. I think some of you probably know. But first thing I'm going to do is I'm going to look at, well, we're balancing our equation. We want to make both sides equal the same amount. So if I look at this side, there's no variable. What's 8 plus 6, everybody? 14. Okay. So 2x plus 6, I need to come up with a number for x that will make this equal 14. So what number do we want to try for x to start us out? Zoe? 1. Okay. So if x is 1, 2 times 1 plus 6. Order of operations, what's 2 times 1? 2. Plus 6 gives me 8. Ooh, we were short. Okay, so this would not work. What else could x be? Haley? 4. All right. So, let me see. I'll just do it down here. So, if x is 4, then I would say 2 times 4 plus 6. And we want it to equal 14. Order of operations, multiplication first, right? 2 times 4 is? 8. Okay. 8 plus 6 is 14. So what is my solution? Emery. X equals 4. And then I'm going to circle it. We have one more example to do together. So you're going to probably see fractions in some of your equations. So we're going to do an example with that. So number 4. So we might have 2/3 x equals 1/3 x plus 1/4. Okay, first glance, how many of you guys are going, oh, no way, I can't do that, way too hard. Okay, let's break it down and make it make sense. So if I look up here, I've got an x here and an x here. That tells me 2/3 times some number, whatever that equals, has to be what this one over here also equals. So we're balancing our equation. So 2/3 of x equals 1/3 of x plus 1/4. Let's try, should we try x equals 1/2 to start us off? Okay, so I'm going to just say x equals 1/2. So I'm using my math reasoning. So yes, it's guess and check, but I'm also using what I know about numbers to try to figure it out. So I'm going to fill 1/2. I'm going to put that wherever there's an x. So 2/3 times, because they're next to each other, 1/2 equals 1/3 times 1/2 plus 1/4. Okay, let's do our math. So if I'm multiplying 2/3 times 1/2, remember I'm multiplying straight across, right? 2 times 1 is? 3 times 2 is? Oh, they're both even. Can somebody reduce that for me? Simplify it? Becca? 1/3. Okay. Now we're going to look at the other side and see if that also equals 1/3. So 1/3 times 1/2 plus 1/4. Order of operations, what will I do first? Selma. 1 times 1? 3 times 2? Okay. Then I take that and I'm adding 1/4. Been a while? Okay. 1/6 plus 1/4. I need my common denominator for 6 and 4. Kyle. 12. Nice work. 4 times 6 times 2 is 12. What I do to the bottom, I do to the top. 1 times 2 is 2. Okay, 2 twelfths plus 3 twelfths is 5 twelfths. Uh-oh, does that work? No. All right. We had a great starting point. What do we want to try next? Jackson?
3/4.
Okay, 3/4. So on your paper, go ahead and try 3/4. See what you get. If x is 3/4. Raise your hand if you have an answer. All right. Emily, what'd you get?
I got, that x equals 3/4 and it works.
It works, doesn't it? So, check your work. So if we filled in x with 3/4, it would make this equation true. Nice job. All right, so guys, today we have evaluated some expressions, some equations for x, and we've used our math reasoning. Now, at your seat, you're going to be doing, it sounds like a lot, but there's not. You're going to be working on pages 225. Might want to write this down.